Okay, so remember that the air movement that we're referring to is air that is in the troposphere. Air cannot rise above the troposphere because the temperature starts increasing with height above this level. So this cooler air right here cannot rise into the warmer air. So we're talking about air movement within the troposphere. We've talked about how air moves and warmer air that is warmed by the surface of the earth. As it warms, it rises and expands. This is less dense air. The air expands because of the reduced pressure as it goes away from the Earth's surface. As the air rises, it cools. So you can see here that the air cools. And as it cools, the molecules go closer together and the air condenses. It becomes more dense and it sinks back down towards the Earth. So we have the air rising here, the warm air rising and expanding, and the cold air sinking and condensing. As the warm air rises up, the cold air or the more dense air will swoop in and take the place of the lower pressured air that's rising. That's how we have wind. So air on Earth doesn't just rise and fall in a straight line. Since our Earth is spinning, we have a Coriolis effect, and that allows for our air to curve. So up here we can see this low pressure happening. We have air that is moving in. We call that converging. It's moving in and up. As it goes in and up, it cools and condenses, and it creates clouds. The air does not just go in and up, though. It also curves. So air that is converging here at the Earth's surface is actually going to spiral inward in a counterclockwise direction. With a high pressure system, the air moves down and out. So in a high pressure system, the air moves down and out. Once again, because we have the Coriolis effect, when the air goes down and it goes out, it actually spirals out on the ground, and it spirals outward in a clockwise direction. So in a low pressure system, we have air moving in and up. When it is converging inward at the Earth's surface, it converges in a counterclockwise direction and then rises up. High pressure systems has cool air sinking and then going outward and diverging at the Earth's surface. When it is diverging, it actually spirals in a clockwise direction as it spirals outward on the ground. We are going to be focusing on the northern hemisphere because we live in the northern hemisphere. Funny enough, in the southern hemisphere, it's actually the opposite. So you can see that in the picture there. So low pressure systems go in and up in counterclockwise direction in the northern hemisphere, but they actually go clockwise in the southern hemisphere. And then here you can see it goes clockwise. Okay, so it's going to go down and out clockwise in the northern hemisphere, but in the southern hemisphere it's actually the opposite. So to review, we have the Earth's surface here. The Earth's surface is going to warm up the air right above it through conduction. That air is going to spiral. Okay, it's going to spiral counterclockwise, and it's going to spiral in and up. As it goes up, it's going to cool and condense. And as it cools and condenses, it will then become more dense and it will begin to sink. It will sink and it will go down and out in a clockwise direction. So air flows from a high pressure system to a low pressure system. It flows from high to low. It is influenced by the Earth's rotation, so it doesn't just simply sink and rise, but it spirals and it flows in a curved path. So we have sinking air spiraling outward in a clockwise direction and swooping in and going counterclockwise as it rotates up at the low pressure system. So the air is going to go down and out, swoop in, go in and up. On your table right now, why don't you practice tracing the movement with your finger? So we're going to be at the high pressure system here. We're going to go air down, then it's going to spiral outward in a clockwise pattern. It's going to swoosh in, go counterclockwise, and back up. So we'll try that one more time. It's good to practice that. You could even draw that on a piece of paper. So your air is going to be sinking because it is more dense. So that cold air is sinking towards the Earth's surface. When it hits the Earth's surface, it's going to diverge. As it diverges, it's going to spiral clockwise. And remember, it's going to swoop in because the air over here is moving in a counterclockwise spiraling position as it is rising. It is rising because as it gets warmed by the Earth's surface, it's going to become less dense as the molecules move away from each other and expand and rise up into the air. In the low pressure system, the air is moving counterclockwise. It's moving counterclockwise as it spirals in and goes up. So we have counterclockwise swirling at the ground, and it's going to go in and up. As the air rises up, it's going to cool and condense, and it's going to create clouds. If you think carefully about that, that would make sense because we have water vapor in the air, and that water vapor is in a gas state. As it rises up, it loses energy, and when it loses energy, it's going to start to condense. So we're going to have then liquid water. So the gas is going to change to a liquid. And as my water vapor becomes liquid water, all of that liquid water then is going to be a bunch of little droplets all gathered together. And the more water droplets I have gathered together forms a cloud. When we have high pressure, the air sinks and goes down. And as it sinks and goes down, it actually dries as it warms. And so we typically will have clear skies and sunny skies. So with high pressure, we have our air that is going to be sinking. So we have cold air sinking. As it sinks, it's going to warm as it gets closer to the Earth's surface, and it's going to dry out, leaving then fair skies. So you're typically going to have sunny skies, very few clouds. The opposite of that would be our low pressure. It's going to be warmed by the Earth's surface. The air is going to be warmed by the Earth's surface as it moves inward. It's going to become less dense as it expands, the air expands. But as it climbs up in altitude, the air is going to start to cool and it's going to start to condense. And like I had just said, when that condenses, it's going to be losing energy as it cools, and it's going to change then from water vapor to liquid. And all of the liquid droplets gathering together then are going to give us clouds and then possible rain. So to recap, we have air going in a counterclockwise direction, spiraling inward at a low pressure area where the air is warm. When that air is warm, it's going to rise. That warm, moist air is going to rise. As it rises upward in altitude, it's going to begin to cool and then condense, and it will possibly form clouds and rain. Okay, the air over here is the high pressure. We have our cold air. Our cold air is going to be sinking because it is more dense. And as it sinks, it's going to release that moisture there and dry up, and it's going to spiral outward. So it's going to go down and out in a clockwise direction. High pressure systems are going to bring us happy weather, brings us sunny, clear skies. Low pressure systems are going to bring us lousy weather, bring stormy weather and clouds and overcast. In our assignment today, we are going to be hunting for highs and lows. We will be hunting for these in the northern hemisphere. So we will be looking for high pressure systems by looking for this clockwise rotation. Low pressure systems will be moving counterclockwise. We will be using the Ventusky link provided to hunt for these highs and lows. This is a view of the Ventusky website that you'll be using. Over here on the left-hand side, you can see that you can press on the different apps and it'll bring you to the different applications for the map. We are going to be focusing on having precipitation. Here it talks about the wind speed, so you could see what the wind speed is at those different locations. But let's use the precipitation because we want to look at that as we look for the different highs and lows. I focused this map. You can see I can move it in and out. So here you can see a broader view, and then I can zoom in. Okay, so here you can see the movement of the air. The wind animation is over here. You can put it on strong or soft or dark. Sometimes dark is good. And then we're going to be looking, first of all, for high pressure. Remember, when we're looking for high pressure, we are going to be looking for a clockwise rotation. So I will use the wind animation that I like the best, and I will look around and hunt for a clockwise rotation that I like. I think I found one there. Okay, so now I'm going to take a screenshot of that area, and then in Notability, I can use my pen to draw the motion of the air. With the high pressure system, that will be in a clockwise rotation, so I can draw that. And then I can also label it high pressure and draw that clockwise rotation. I can do the same thing for the low pressure next to it. I can see here that there is this counterclockwise rotation, and I can label that one low pressure and show that counterclockwise rotation. The cool thing about using the precipitation app is that you can see the actual precipitation that's happening. So remember that when we have low pressure in this counterclockwise rotation here, there is warm air rising, and as it rises, it cools and condenses and makes clouds and precipitation. So we can actually see the precipitation happening at the low pressure systems. Over here at this clockwise rotation, we have high pressure, and you can see that there is no precipitation where the high pressure system is. Okay, so now in the assignment, it asks us to go to air pressure. So I'm going to click on the air pressure app. Over on the right-hand side, I am going to change the pressure to hectopascals. And this is formerly known as millibars. And so we're going to use the millibars to look at the different pressure. So here at the high pressure system, you can see that we have 1035 or 1034 here at the center. So over here you can see the colors. So we have a higher pressure at the center here. And then as we spiral outward, you can see that it gets lower out here. So this is our high pressure system. And you can see that as it spirals out. So you can see there's a higher pressure at the center of the high pressure system. Over here at the low pressure system, you can see it's the opposite. So we have our low pressure here in the greens and the blues. And so you can see there's greens and blues here, the blue, then the green, then the yellow. And so it is increasing as it goes outward. So it is a lower pressure at the center, and then at the high pressure, it is a higher pressure at the center. So this color chart here can really show you where the highs and lows are. Take a screenshot and label it again. Now we are going to fill out the table with the data that we just collected. So we're going to look at high pressure and write down whether it is a clockwise or counterclockwise motion. We're going to record what millibars were at the center of that high pressure. And we're going to describe whether we saw precipitation or no precipitation at the high pressure systems. We'll do the exact same thing then for the low pressure systems. You'll Dropbox this when you're all done.